The whole world moves on tires. And tires move on rubber compounds reinforced with cord. Cord fabric gives a tire strength. It helps a tire keep its shape and durability. No one in the world knows more about tire cord than Dunlop, a name already respected over 5 continents. Dunlop Textiles, based in the United Kingdom, have studied the science of tire cord for 70 years. They spin and weave tire cord fabric in Dunfermline, Scotland. And at this plant, their headquarters in Rochdale, they hot stretch it evenly and dip it in special adhesive mixes so that it molds properly into the tire formation. The cord forms the reinforcing layers in tires throughout the world for cars, trucks, heavy-duty industrial vehicles, aircraft, anything with wheels. This heat set and dipping plant, built locally under license from the American company C.A. Litzler, is one of the most modern in Europe. Dunlop have operated it for nearly 20 years. They have unrivaled knowledge and experience of quality tire cord processing. Basically, the plant is a series of stretching units, ovens and dipping tanks. A continuous 450-meter web of tire cord can move at 80 meters a minute through the system. Smaller plants would operate at a slower rate, but in a similar way. A newly woven roll of fabric, polyester, nylon, rayon or Kevlar, arrives at the plant in special wrapping. Contamination and excessive moisture can affect the adhesion qualities. The roll is sewn onto the existing fabric as it runs through the plant, without stopping it in any way. This is managed by a festoon accumulator system, which on this machine can store over 200 meters of fabric before it's drawn through. Once on its way, the fabric passes through the master tension stand with a series of rollers turning at precisely the same speed. If the fabric is not stretched and heat set between a series of tension stands, it could shrink in the heat of the tire-making process. Stretching now also prevents it stretching later in the tire. Nylon, for trucks, aircraft and earth-moving equipment, is stretched as much as 10%, polyester up to 2%. Polyester would then enter the first dipping bath of epoxy resin and isocyanate. Any excess is taken off by suction at a precise vacuum to control adhesive pickup and piped back into the dip bath. The fabric web enters the first oven to set the tensioned cords. The 25-meter high ovens here can be heated up to 288 degrees centigrade by natural gas. Other fuels can be used. The temperature at various points is controlled by hot or cool air blown through nozzles. Exposure to the hot air in seconds is critical, monitored automatically or manually at the computer control board. Leaving the oven, the fabric passes through another tension stand for stretching or relaxing, before entering a second oven to set the new tension. It is then taken through yet another tension stand on its way to the second dipping unit. This contains a solution of latex, resorcinol, and formaldehyde. Nylon would be dipped in this solution only. Another nozzle takes off the excess as the fabric goes into the third and fourth ovens. before entering a cooling pass and the fourth final tension stand. The sophisticated combination of ovens, dipping units, and tension stands allow precise settings and treatment for cord weave of any kind. Finally, the fabric is collected in another accumulator before it's wound onto a reel under a uniform tensioning system. Throughout the operation, electrical sensors trigger devices shown in yellow to keep the fabric taut, straight, and clean. There is a dust and fabric extractor, curved expander rollers at key points to spread the 1.5 meter web evenly across the machine, and roll-inners to keep the edges uniform and straight. The cord spacing is exact, vital for modern high-performance tires. The dipping solutions are mixed in the plant and, after maturing for several hours, can be stored in 9,000-litre tanks. Regular tests are made on the mixes to check pH levels, total solids, viscosity, and adhesion qualities. Quality assurance and process control are important aspects of Dunlop Textiles operations. Rolls of treated fabric are put through stringent checks. A tensile test can show the breaking force and extension of cord at particular loads, such as 4.5 or 6.6 kilos. Other checks are made on shrinkage, twist, and adhesion. It must take at least a 12 or 14 kilo force to pull a cord from a 1 centimeter rubber block. The whole plant is duplicated in miniature in the laboratories for easily assessing the total effect on a single cord. Dunlop have learned the full techniques of running the plant through long experimentation and experience. Their technicians work closely with yarn suppliers and customers throughout the UK, Europe, and Africa.
ICI Fibres has had a long-term relationship with the whole Dunlop Group, and especially Dunlop Textiles. As the local supplier of high-tenacity synthetic yarns for the tyre industry, we've obviously had a key role in tyre development. And most of the original work on the use of polyester in tyres for Europe was done between Dunlop and ICI Fibres. And that sort of relationship continues today and I think is getting even stronger. My objective is to produce new fabrics for the tyre industry. And for me, that's the critical point. It isn't necessarily the properties of the yarn that we manufacture that's important. It's the properties of the final fabric. And in that way, I'm very dependent upon Dunlop to convert the yarns into fabrics. I've worked with Dunlop for a number of years now on new projects, and the depth of their technical expertise and the flexibility of the equipment has allowed us to engineer the fabric properties very precisely and therefore successfully develop a number of new products for the tyre industry.
Dunlop's skills allow them to operate this versatile plant for the whole range of more than 70 tyre cord specifications. They have installed similar plants in the United States and India, with training and full operating support.
Tyre cord fabrics are one of the most vital components in the manufacture of tyres, and we here at Dunlop Textiles are one of the leading suppliers of tyre cord fabrics. We have been producing tyre cord fabrics for over 70 years, and throughout that period we have been at the forefront of technological change and innovation. For example, we were one of the first companies to see the opportunities presented by the use of man-made fibres, and since then we have switched from the use of cotton to the wide range of artificial fibres that are now available today. 20 years ago we took another major step forward with the design and installation of our own specialist finishing plant for fabrics. Such has been its success that even today our competitors are still trying to catch up. Here at Dunlop Textiles, we have the experience, the commitment and the financial resources to ensure we remain a world leader in tire cord fabrics.
With Dunlop, you get not only the technology and service, you also get the experience. No one else has so much to offer.